Hey, today I'll be doing a recap of all of the new material we just covered to help you prepare for your test. As you may recall, we have just done fundamental counting principle, factorials, permutations, and combinations. So I'm going to work through a few of these problems. For factorials, we simply multiply the original number by every number less than that going down by 1. So for 6 factorial, we'd have 6 times 5 times 4 times 3 times 2 times 1. And when we do that, we get 720. When we divide factorials, we still write them out. So for 11 factorial, we would have 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1 over 7 times 6 times 5 times 4 times 3, 2, 1. And remember, the numbers on top cancel out the numbers on bottom that match. So we can cross these out because they just equal 1. So then we're just left with 11 times 10 times 9 times 8. And that is 7920. Another way we can do that we have actually just learned. Another way to quickly simplify, we could do 11 times 10 times 9 times 8 times 7 factorial, so that way we don't have to write all the way to 1 over 7 factorial. And our 7 factorials cancel, and we get the same answer. That prevents you from having to write all the way to 1. When we do our abstract factorials, we do the same thing. We're always going down towards 1, or we're always going down by 1. So if we start out with n plus 2 factorial, our first one is n plus 2. And then 1 less than n plus 2 is n plus 1. We're going to go down until, notice n minus 1, and we have n minus 1 on the bottom. So we could say n minus 1 factorial, and then n minus 1 factorial. Because n minus 1 is going to keep going down all the way to 1, and so is n minus 1 down here. They're going to go down all the way to 1. So we're able to cancel these. And then when we multiply them out, do that over here. We have n plus 2. I'll do the first two first. Do our n's. We get n squared. And in the 1, you get plus n, not 1n. 2 times n is 2n, and 2 times 1 is 2. Can rewrite this as n squared plus 3n, that's 2n plus n. We combine our like terms, plus 2. But now we have to multiply it by n, because we still have the n over here that we have to multiply by. So when we distribute the n in here, we get n cubed. That's supposed to be n squared. I know it's hard to read. And then you get plus 3n squared, and then distribute the last one, plus 2n. Oh, sorry guys. And that's your final answer for the first one. N cubed plus 3n squared plus 2n. Whenever you're distributing, take them 2 at a time. It'll make it a lot easier. For the next one, we have n minus 2 factorial over n. So on the top, I start with n minus 2. The next one will be n minus 3. Always go down by 1 each time. Almost made that mistake. 1 less than n minus 3 is n minus 4. On the bottom, it's n factorial, so we start with n. Our next one, 1 less than n, will be n minus 1, and n minus 2, n minus 3. As you guys know, we have a pattern. N minus 2 all the way down cancel, so n minus 2, n minus 2. we're left with 1 over n times n minus 1. You have to have the 1 over or else the answer will be incorrect. Your numbers were left in the denominator, so you have to have that 1 there as a placeholder. And this is equivalent to 1 over n squared minus n. For our fundamental counting principle, we have a standard North Carolina license plate can only have 3 letters and 4 numbers. How many different license plates can be made if only 3 letters can repeat? So we can have 3 letters and 4 numbers. Now pay attention, it says if only the letters can repeat. So the letters can repeat, but not the digits. So if our letters can repeat, then that means we have 26 letters to choose from, A through Z. They can repeat, so we have 26 for the first 3. But our digits, it doesn't say our digits can repeat, so we have to assume that they can't, or it would have said it in the instructions. So that means we have 10 digits to choose from, but once we use one, there's only 9 left, then 8 left, then 7 left. When we multiply this out, let me grab my calculator. We have 88,583,040. That's our answer for when we multiply that one out. So now we can also have permutations without repetition. Remember that this formula is n factorial over n minus r factorial. So this problem is SGA is electing a new president, vice president, secretary, and treasurer this year. If there are 18 people running for an office position, how many arrangements are possible? So we know we have NPR for permutation, and in this case it says that 18 people are running, so we have 18, and there are 1, 2, 3, 4 positions for treasurer. So it's 18 permutate 4. The reason we do permutation is because order matters. If someone gets elected president and someone gets elected vice president, if they switch, it is not the same thing like we did in class. So when I'm solving this, I'll work it over here so you can see it a little bit better. I'll have 18 factorial over 18 minus 4 factorial, which equals 18 factorial over 14 factorial. When I write this out, I get 18 times 17 times 16, 15 times 14 factorial, because I can stop there, it matches the bottom, over 14 factorial. When those cancel, I'm left with 18 times 17 times 16 times 15, which equals 73,440. So that's permutation without repetition. Next we do permutation with repetition. Our equation for this one is n factorial over p factorial, q factorial, and r factorial. P, q, and r simply represent the number of letters that are being repeated, or the number of digits or anything we're using that is being repeated. So in this example, we're doing how many different ways can you rearrange the word bananas? Well, first of all, let's see what we have multiple of. We have 3 A's, and we have 2 N's. So when we're writing that, we'll have n factorial, which is our total number of letters, 1, 2, 3, 4, 5, 6, 7. 7 factorial over, we have 3 N's and, or 3 A's and 2 N's. When you simplify that, you have 7 times 6 times 5 times 4 times 3 factorial over 3 factorial 2 times 1. So your 3 factorials cancel, and you have 7 times 6 times 5 times 4 divided by 2 times 1, which gives you 420. That's how many different ways you can rearrange the word bananas. Finally, we have combinations. And our combination formula is n factorial over r factorial times n minus r factorial. So when we're doing that, we can see that, or in this problem we have, if 8 people eat dinner together, how many different ways can 3 people order chicken and 5 people order steak? Notice order doesn't matter too much. It doesn't matter what 3 people eat chicken, and if those 3 people rearrange, they're still eating chicken. So that's why it is a combination for this one. And the way you do it is take it one classification at a time. So if we're doing chicken first, we have 8 people to choose from, and 3 of them are getting chicken. Well, once 3 have been chosen for chicken, there's only 5 people left. And 5 people are ordering steak, so we're just rearranging those 5 people to order steak. So once we put this in the formula, you would have 8 factorial over 3 factorial, 8 minus 3 factorial times 5 factorial over 5 factorial, 5 minus 5 factorial. This simplifies to 8 factorial over 3 factorial, 5 factorial times 5 factorial over 5 factorial, and 5 minus 5 is 0, 0 factorial. So when we simplify all of these out, oh, sorry guys. When we simplify all these, we would have 8 times 7 times 6 times 5 factorial over 3 times 2 times 1 times 5 factorial, those cancel, times, this one you have 5 factorial over 5 factorial is already 1, so then you have 1 over 0 factorial. Well, 0 factorial is 1, so actually you only have to solve this section. And with this one you get 8 times 7 times 6 divided by 3 times 2, and you get 56. So there are 56 different ways that 8 people can eat dinner, in which 3 eat chicken and 5 eat steak. Good luck on your test, guys. I know you'll do great.